Hey everyone, good day. Hope you're all doing great. Um, we're going to just walk through a short presentation now on decomposition. Decomposition is an absolutely critical way of solving complex problems. And essentially, it says that when you have a complex problem, the first thing to do is to find ways to break it down into smaller problems that you can solve. But there are many ways of breaking things down. You can break them down functionally, you can break them down if it's a computer program by events, and all that. So we're going to go through composition now, decomposition, and how you can use it very quickly. All right. So essentially, everything in the world is made up of smaller parts. Everything in the world, as long as it's not an atom, you see, it is made up of smaller parts. Whether it's an object or a system or even an idea. Ideas are composed of smaller ideas. Systems are composed of smaller systems, and objects are composed of smaller objects. So when you reverse that, you can take an idea or a system or an object and break it into smaller parts and then solve them. All right. Now, take this as a system, for instance, how rain falls. Rain falls by the clouds, as you can see, coming together, getting heavy, and then you have the rain drops. And they drop into onto the land and the bodies of water that would now be, that will now evaporate, okay, because of sunlight, right? And then come back, well, they evaporate, back into clouds, and then the wind pushes them together again and they fall. So you could say, for instance, that this is a system, okay, and if you think about how it's composed, you might think about it in terms of the clouds, coming together of the clouds, all right? The system that allows them to get heavy and to rain, and then the system that allows them to collect into bodies of water again and to be the evaporation by the sun. See, so this is a system that you can decompose into smaller parts. Essentially, also, you could think about a more complex thing, such as this car right here. Okay. Now, what we're saying is that, okay, here's a car made up of so many other parts. But if there were to be a problem, how would you think, you would decompose this? Okay. You might say, for purposes of what you want to achieve, that let's divide this car into the bonnet section, the cabin section, okay, and the boot section. That's fantastic. You have decomposed it into bisections. However, what if you wanted to say, all right, let's talk about the mechanical parts, okay, made up of the engine, the wheels, other mechanical parts, the electrical parts, lights, pumps, the dashboard and hi-fi system and all that, okay, and then other soft parts like the frame of the car, the interior, the chairs and all that. That begins to give you an idea that things could be decomposed in many ways depending on what you want to achieve, okay, but everything is made up of smaller parts, and when you decompose them, then you're able to solve problems much easier. Here is another example. Now, this is some math. Take a look at this equation. It's a simultaneous equation. And the simultaneous equation can be solved by isolating x and isolating y and solving each of them and then putting them back into, solving one and putting them back into the equation to solve for the other. So you can decompose by isolating any of them and then bringing them back. But if you think about an equation such as this, what would have happened is that the world, okay, something in our physical space, all right, or in our social space, or in our economic space, okay, people have understood it and have been able to decompose it into an equation such as this. Now, when they solve this equation, then they will be able to solve the bigger or more complex problem. You see, so that is decomposition for you. Now you could also think about, a library. All right. So a library is composed of different kinds of books. When you go into a library, you see different sections. You can have a section for fiction, right? You can have a section for biographies, right? You can have a section for news articles. You can have a section for journals. Okay, so all of those together, make up a library. Now, when you want to decompose a library, you now decompose them by books in fiction, biographies, journals, newspapers, religious text, textbooks, and what have you. Even when you take a book, okay, like this, you can decompose a book into chapters, right? Chapter 1, chapter 2, chapter 3. When you take a chapter, you can decompose it into sections. For instance, chapters would have sections. All right. When you take a section, you can decompose them into, imagine that the section is like an essay. You can decompose that into paragraphs. Okay. Paragraphs. When you take a paragraph, you can decompose it into words, smaller words. And when you take a word, you can decompose it into letters. All right. And what have you. So that's just the way the world is. Think about how things could be broken down into smaller parts, and when you solve them, you would essentially have been able to solve that bigger problem. Finally, let's look at a very simple line of code. Every computer program is made up of lines of code such as this, and every line of code does something. So these are two lines of code. What's going on here? First thing is that we create a variable called var name. Variable is like a container, it stores anything you put inside it. But we're not asking the computer, hey, tell the user to give us his name. All right, so we ask for your name using this function called input, and then we store it in the variable. And then the next line says, all right, take that user's name that has been stored in the variable, add it to the word hello, and print it. That's awesome. Every line here has a function, but within the lines, you see, you can also have multiple things happening. So when you decompose the problem saying, I want to put my name into a computer and I want to be able to get it out. All right, then we have to think about the components of that and how a computer can do that. See, so when we have been able to code this into a program, then it can run again and again, which is the essence of computational thinking, creating a solution to a problem that could be used, to create a program that can run again and again. So in a nutshell, this is decomposition, and as the course goes on, it would have lots and lots of tasks and avenues to practice decomposition. Thanks again.